Okay, so looking at this, we're gonna start graphing our polynomials. Now keep in mind these are just going to be rough sketches. Okay, so just starting off with number 1 and 2, I would write down my leading term. Remember, your leading term is going to be the term with the biggest degree. So that's negative x to the fourth. Your leading coefficient is going to be the number out in front of negative x to the fourth, which would be negative 1. And your degree is going to be whatever the exponent is, which is 4. My right-hand behavior is going to be what the right side of my graph is doing. For example, if I drew a quadratic that looks, say, something like this, well, this is my right-hand behavior. As x goes to infinity, my y value I am approaching, it's going to go up forever. So my right-hand behavior of this graph would be y is going to be approaching infinity. So in this case, since my a value is negative, just like y'all are familiar with a quadratic, if my a value is negative, notice my right-hand bound is going to be going down forever. So my right-hand bound will be negative infinity. If the degree is even, your left-hand bound will go the exact same direction. Okay? The next one, for us to get our leading term, we'd have to multiply that, which would give me x cubed. The leading coefficient out in front would be 1, and the degree is 3. I'm going through this a little quick because we did these in the last class. My right-hand bound, once again, is going to be based on this leading coefficient. Since it is positive, my right-hand bound will be going to infinity. If my degree is odd, then my left-hand bound will go the opposite direction. So since my right side is going to infinity, my left bound will go to negative infinity. Once again, please keep in mind your right-hand bound and left-hand bound are y values. What y value is it approaching? Okay? Multiplicity is going to be how many times the actual root occurs. So each 0, in other words, where it crosses the x-axis, has a multiplicity. This multiplicity is going to determine how the graph is drawn at that root, or where we draw it at the x-intercept. So, for example, you've seen a line before, correct? This right here crosses the graph, which would be an example of a multiplicity of 1. Okay? You've seen a quadratic that where the vertex sits on. This would be considered a bounce. If it bounces, then it's going to be a multiplicity of 2. And what's going to happen is if the multiplicity is odd, it's going to cross. If it's even, it's going to bounce. So then we've seen like a cubic. This right here, these each cross, right? So each one of these would be a multiplicity of 1. In other words, each one of those roots only occurs one time, and you'll understand that a little bit more in a second. You could also have this type of scenario with a cubic. So this one crosses, so it has a multiplicity of 1, whereas this one bounces, so it's going to have a multiplicity of 2. Okay, so now let's see if we can't figure out what all that means. Looking at this, when I talk about a multiplicity of 2, well, what you'll notice is this x plus 1, well, it occurs twice. That's going to be a multiplicity of 2. So when I look at this, this is supposed to be, if I want to find my roots, that's where y equals 0, correct? So that means I'm going to take this and I'm going to set it equal to 0. So if I have x plus 1 equals 0, then x is going to equal negative 1. Keep in mind, this was a multiplicity of 2, so I would write the root x equals negative 1 multiplicity of 2. And it is a multiplicity of 2 because, look, I got that answer 2 times. The next thing I would do would take x minus 2 equals 0. So if I solve for x, I would get x equals 2. That only occurs once, so I have 2 multiplicity of 1, of 1, 2 multiplicity of 1. The last one would be x minus 4, so x equals 4. And what you'll notice is the sign's just going to change on these. I had a positive 1 on the inside, I'm going to have a negative 1 on the outside, I have a negative 2 on the inside, positive 2 on the outside, negative 4 becomes a positive. So I'm going to go ahead and graph these roots. Negative 1 would just be a tick mark right there. It's a multiplicity of 2, so I'm going to leave myself a note with a B for bounces. The next one is a root at 2, and this one is a multiplicity of 1, so it's going to cross. And then after that I have 4, which once again is a multiplicity of 1, which crosses. So now, if I wanted to find my y-intercept, that's the same thing as if I plug in 0 for x. So that would be 0 plus 1, 0 plus 1, 0 minus 2, and 0 minus 4. This would end up being 1, 1, 0 minus 2 is negative 2, and 0 plus 4 is 4. 1 times negative 2 times negative 4, is going to be 8. So my y-intercept is 0, 8. So you could do tick marks, or you could just label your y-intercept like I just did. To find your leading term, you're going to need to multiply all of your variables. So it would be x times x times x times x, which would give me x to the 4th. My leading coefficient is 1, and my degree is 4. The right-hand behavior, since my leading coefficient is positive, this is going to go to positive infinity. My left-hand behavior, since my degree is even, they're going to go the same direction. So now I want to start off at my far right. My right-hand behavior says it's going to go to infinity. So at my root on the right, I'm going to go up to infinity. I am then supposed to cross at that root, but I have to come back up and cross at the other root and then go up to my y-intercept. For my y-intercept, I have to come back down. To this root, I have to bounce and go back up to infinity. Notice my left-hand bound says it's going to go to infinity. My graph is going to infinity. So let's look at the next one. That first one, it was factored for us. You'll notice this next one is not factored for us. I'm going to factor out a negative x. So that's going to leave me with x squared minus 6x, plus 6x, plus 9. This right here, I'm going to have to factor. So if I were to factor that, I'd get 9 on top, 6 on the bottom. I need two numbers that multiply to give me 9 and combine to give me 6. So let's see, I got this negative x, then I'm going to have what? X squared plus 3x plus 3x plus 9. Then we're going to group these. That's a negative x, the first two have an x in common, leaving me with x plus 3. I need to put this as a bar. And then the last two have a 3 in common, leaving me with x plus 3. You might have already figured out by now this is a perfect square. So I'm left with negative x, this on the outside, right? Then these are one of my factors. And then this will be my other factor. So I have negative x, x plus 3 squared. To find my roots, I need to set those equal to 0. Negative x equals 0, and x plus 3 equals 0. Oops, that's a 0, sorry. Negative x equals 0 means x equals 0. Since it only occurs once, it is a multiplicity of 1. X equals negative 3. Remember, that is squared, correct? Since it is squared, it's negative 3 multiplicity of 2. So now I'm going to go down. Once again, I'm going to plot those two. At 0, it's a multiplicity of 1, so it's going to cross. At negative 3, it's a multiplicity of 2, so it's going to bounce. If I were to plug in 0, I would have negative 0 cubed minus 6, 0 squared minus 9 times 0. Notice the answer to this is going to be 0, which means my y-intercept is 0. Your constant in your standard equation is always going to be your y-intercept. So in this case, I actually have a root at the y-intercept. My leading term is negative x cubed. Remember, your leading term is going to be the term with the biggest degree. My leading coefficient will be the number out in front, which is negative 1. My degree is 3. My right-hand bound is based on this negative 1, which means it's going to go to negative infinity. My left-hand bound is based on an odd degree, so it will go the opposite direction. Go to your right root. From your right, you should go down to negative infinity. At that root, we're supposed to cross, come up, we have to come back down to our root. At this root, we're supposed to bounce and go back up. Notice the left end of my graph is going to infinity, which matches the left end bound of infinity. Is that all I had for those? Yep. So that's those two. Now working the other direction. Sometimes it helps to work the other direction to see where this all comes from. This root right here crosses, which means it's going to be a multiplicity of 1. This root crosses, so it's a multiplicity of 1. And this root crosses, so it's a multiplicity of 1. So if I were to write those roots down, I have a root of -4, multiplicity 1. I have a root of 0, multiplicity 1. And I have a root of 3, multiplicity 1. If I am going to find the equation for that, I need y equals, remember I do not know a. -4 will become +4 on the inside. Since it's a multiplicity of 1, I don't need to put anything. This 0, you could put x plus 0, but in actuality you can also just put an x, which is how I would do it. So in other words, I would actually write that a x plus 4, x minus 3. After that, you're going to take the point they gave you and plug it in. Since the y is -10, this will be -10, and all my x's will be 1. After that, I am solving for a. So if you'll look at this, let's see, we get 1 plus 4 is 5. 1 minus 3 is -2. So I'm left with -10 equals -10a. So a is going to equal 1. Therefore, I can write my equation as y equals, I don't need to put 1 for a, and I'll put x plus 4, and x minus 3. So let's try another one of these. This graph bounces, so it's a multiplicity of 2. This root crosses, so it's a multiplicity of 1. So if I were to write my roots, we've got -3, multiplicity 2, and 1, multiplicity of 1. We've got to find the a value, so we're going to write y equals a. Remember, on the inside it's going to change the sign, and this is squared because it's a multiplicity of 1. X minus 1, since it's a multiplicity of 1, it's fine like that. I'm going to plug in my 3 for y, and then I'm going to plug in my -2 for x. So let's see, I got 3, -2 plus 3 is 1, 1 squared is 1, -2, -1 is -3. So I end up with 3 equals -3a, so a equals -1, which makes sense because my right-hand bound is going down to -infinity. So my equation looks like y equals -x plus 3 squared x minus 1. Okay? Hope this helps.